Where did you get that shirt, Max? It's the one in the photo. It's really nice.
At my former employer. So
Ah,
before, there we got this huge discount, and before I left, I bought like quite some shirts.
makes sense. Well, we don't have shirts at Jina, but we do have custom nail polish now with the Jina logo.
I have to go to you, and you have to give me a session next week. Then I also get this.
All right. Yeah, well, we've got like quite a few people now, so let's get the show on the road. Nan, can you keep an eye on the chat? And just, yeah, if there are any important messages coming up, let me know.
Yeah, no problem.
Thank you. Okay, so yes, welcome once again to Jina's Engineering All Hands, yet another installment. Almost the last of the year. So it's great to see you all again. Always a pleasure. This time round, our engineer Max is going to give a talk on Jina's new Finetuner and how it can help improve your search results. Before that, just a few news points I'd like to go over. So first up, we've just hit 12,000 stars and 5,000 LinkedIn followers. So big thank you to the community. You all rock. We're currently doing our 14 days of Jina challenge with Featurepreneur. Some great projects are coming out of that, like really top-notch stuff. So kudos to everyone involved. We've now got a whole bunch of data type tutorials on docs.jina.ai that teach you how to use different data types with Jina, like text, audio, video, images, 3D meshes, a whole bunch of stuff. So if you need to learn how to use those, go straight there. And we've just redesigned Jina Hub as well. So it's even easier to find the executor you need, and you can use it with just a few lines of code. If you're here, you probably already know what Engineering All Hands is. We run it every second Tuesday of the month. It's a way to interact with our community, let you know what's coming soon. Yeah, I don't think I need to explain what Jina is, unless you somehow accidentally came to this webinar, in which case, what are the odds? So any questions, stick them in the questions tab. Any chit chat, do it in the chat tab. If you want other people to see, be sure to mark everybody. There's a little box that says hosts and participants by default. Click that, then click everyone. And if you click in everyone, keep it clean, keep it nice. We're children friendly here, family friendly. All right, yeah, we'll answer any questions at the end. And yeah, without further ado, I'll hand it over to Max.
Thanks a lot. Let me share my screen. I hope you can see the slides in full screen.
They are indeed.
Perfect. Yes. So in case you have any questions in between, Alex and Nan, just interrupt me and read them, and I can somehow answer them in between. So yeah, don't worry. I'm always happy to take questions directly in the middle and not all at the end, because I can directly react to it. I think that's much better. So when you go to a lawyer and you ask a theoretical or practical question, most probably one of the first sentences you will get is "it depends." Depending what is your case in front of the law. When you come to me and ask me, oh, how can I build my best search and how can I somehow get really good search results? I will say it depends. It depends on your use case. It depends on your customers. It depends heavily on your data. So I will try to shed some light, how we try to shed light in Jina on these depends questions. And we do this via the Finetuner, and I will have a look into it. So in the beginning, I will give some motivation why we built the Finetuner, why we started with the project. Then afterwards, I will show some short-term and long-term goals. So differentiate between what we do in the next 2 to 3 months and what we want to do in the next year. Afterwards, I will show details and demo. Several demos. I will play around a little bit with it. And I'm happy also there if you have questions about how to use it and why we designed things like we have. And at the end, I will give you an outlook about the next features and what will happen quite soonish on more technical level than the goals at the beginning. So without further ado, let's go to the motivation. If you've followed Jina, and if not, then I will explain you now what happened in the past. You will know that there is Jina core, or the Jina itself, the framework, and this helps you build a search service. This gives you infrastructure. This gives you the pointer's nicer. This helps you scale your infrastructure. It's defines data types. Then once you have transformed your data into the Jina data types, it's much easier to use Jina, and somehow you have a native way to use Jina. It takes care about network communication. It takes care about the pain in Python that when you want to have different modules, perhaps one model in TensorFlow, one in Python, in PyTorch, or you also want to use FICE or other dependencies, about installing them, about putting them on different machines, Dockerizing everything. So Jina helps you with all the infrastructure tasks that you have when you want to build a neural search. Then we introduced the hub. The hub takes care about distributing the building blocks. So once someone has a nice idea, a nice algorithm, has a model that he wants to wrap and make easily usable inside Jina, you can find them on the hub and you can just use them. And it makes it easy for yourself to somehow reuse your models or your executors. And it makes it easy for others to somehow help you using theirs. So this adds a social component also to the whole Jina world and a sharing component. But so far, it's just about infrastructure and about, okay, getting code to run, but not so much about really getting top of the notch quality. And for this, we introduce a Finetuner, and the main goal is improve the search quality. Somehow first discover, okay, how can we really reach better search quality? And then later on, really show this and really somehow give this tool into the hands of our users to enable them to get better search results. So let me start with an analogy before I go into details how the Finetuner works and what it is. So let's take the task of drawing a sunflower. Most probably when I draw a sunflower, or actually when I draw a sunflower, it looks like on the left-hand side. That was me drawing one. If you ask my grandmother, who have done quite some drawing in her life, most probably it looks nicer. She has not practiced on sunflowers, but still it will look much nicer than mine. But if you ask an artist who practiced somehow drawing sunflowers quite extensively and also practiced drawing way more than my grandmother, you get a piece of art. You get much better result. It is somehow similar to information retrieval. So let's say we want to find a blue t-shirt. Well, some bad model or random model might get you something like on the left-hand side. Well, at least there are docs in there and there's blue and there's closing, but the semantics are absolutely not somehow covered. The model in the middle, which might be an off-the-shelf model, might get some semantics like a blue t-shirt, but might still miss the text part or the docs part. But you still get better results in the correct semantic space, but not the details in your specific domain. But when you think about a fine-tuned model, this will somehow capture all the parts in this search question from above and somehow try to give you or it will give you the right results that capture all the semantics. So you have a blue t-shirt and there's text about docs. But the semantics may change quite fast. So let's say I want to search for shirt, blue docs. Well, obviously, in the middle, the shirt in the middle is wrong because there's nothing about docs. It's just a blue shirt. But is the left-hand side the correct answer or the right-hand side? Well, it depends. If you have an online shop about animal food, and by chance you also have animal clothings, quite extensive, and you just have one or two t-shirts about where also some of funny text is on, well, potentially the left-hand side is the right answer. If you have a shop where you mostly sell real like t-shirts, a t-shirt shop, where like 90% of your inventory is the right-hand side, like t-shirts with text, and there might be one or two also fun things for shirts for dogs, potentially the right-hand side is the correct one. Potentially also depends on the context of the user. But my point is, it's not obvious which one's the right answer. You only know it once you know the context of the search and of the use application in search itself. And what we want to reach in Jina, we want to be part of the new AI supply chain. You might have seen this slide before when you have followed Jina. I think Han, our CEO, has created this image 2 or 3 years ago. And the takeaway from this slide is they're big tech giants, and they will produce big pre-trained models like GT3, like Clip. So big models which takes a lot of effort to train them. And they somehow open source them. They give it to the world, or not always, but quite often. But most probably not everyone who wants to build neural search is able to build such a model with a lot of extensive training data, with a lot of knowledge that you need to know about training machine learning models, and with access to so many GPUs and resources to actually train the model. So it's quite expensive. What happened in the past is that Hugging Face did quite a good job in somehow enabling the AI community to access these pre-trained models. And so the AI community now has really good access to all the pre-trained models and can easily use them, and that's pretty cool. But the missing part is still to somehow fine-tune the models to the application at hand. So let's say it might be the application of, you have speakers like Alexa and so on, where you want to apply machine learning, or something in car driving, car detection, whatever it might be, in vehicle detection, or other things like text, voice understanding, and so on. So there might be various applications where the model out of the box doesn't work good, perhaps sometimes good, perhaps sometimes not, but you need to tweak this model to the actual application. And this is where the fine-tuner somehow lives. The fine-tuner wants to solve exactly this problem. Are there any questions or comments so far before I go to our goals, to the introduction? Anything unclear? No raised hands, so I guess not. Then I will continue. So what are the concrete goals of the fine-tuner? So in the short term, we want to be the last mile delivery for information retrieval and search tasks. So what I said in the last slide, where I said we want to be the last part of the funnel. But for now, we want to explicitly, for us, shorten the iteration cycles for quality improvements. So we want to build small tools which help us understanding information retrieval on a general scale better, and also help you to understand information retrieval better. And ideally, we want to be these tools to live long and also be usable in the future. But for now, we mostly concentrate on understanding fine-tuning more and more, and help you understand fine-tuning more. Because fine-tuning is mostly quite different from training from scratch. You need less data. Ideally, you need just several hundred of data points, and then you somehow, with augmentation techniques, you don't need to do much more. So, and you want to not train like hours or days. Ideally, you want to train for 5 minutes, and then you get a new model which has improved qualities. So, but in the short term, we mostly focus on developing these tools for us to afterwards develop even better tools for you. Which doesn't mean that you can't use them now. I think they're quite nice to use and to get a good understanding what fine-tuning means and how you can apply fine-tuning. But please don't wonder if you feel like, okay, now I have my problem and my data and I want to immediately get better results. Most probably that doesn't work in the next week, but perhaps in 2 or 3 months, we hope for. And for now, our users of the fine-tuner needs to have knowledge about their data. They need to know their models. They need to have some idea about machine learning, and also they need the domain knowledge. In the long term, we want that the users only care about data and domain knowledge. We want somehow to free the user from this need to have a deep understanding of machine learning. So in the long term, we want to change our fine-tuner and also the front end into a guide that takes our users by the hand. So it should be easy for the user to somehow put their domain knowledge into the model and somehow teach the model their domain knowledge without understanding what a model is. Or perhaps rough understanding what a model is, but not deep understanding of the model at hand. And ideally, we want to achieve obviously top-notch search results. And apart from user that already knows somehow what wants somehow to search and wants then to get better search results and teach the model better things, we also want to solve a problem which may sound weird, but actually is for a lot of people in information retrieval the actual problem. The most users don't even know what a good search result look like. And don't talk about your customers that somehow use your search box, but about the people that develop search engines in let's say for their own web shop, for whatever they want. Often they think they know what a good search results look like, but when we ask concretely, let's give me a question, give me 10 answers that are good and 10 answers that are bad, and 10 that are neither bad nor good. This is a really hard task actually often. So when you think about, oh, what will my customers search for, and what do they really expect to be good, to be there, this is often harder than you think. And we want somehow in the future to make our customers, so our users of Jina, we will want to enable them that they somehow can solve this problem for themselves, that they can understand what problem they actually try to solve and afterwards solve it. And one goal that we have, which is somehow for the ML community more interesting, we want to support PyTorch, TensorFlow, and Paddle out of the box, and somehow we have a more or less unified interface for quite some components of them that you somehow can switch models quite easily without needing to change your training data, without needing to change a lot of the custom for your problem things that you design. Any questions regarding the goals or any comments or things that you like to discuss, agree with or disagree with? I will give you a moment if you want to write something,
Or raise your hand and we'll open up the mic and yeah, you can ask in person. We can hear your lovely voice.
Okay.
Okay, I guess it was so self-explanatory that no questions.
But in case there is one question popping up also in between, just interrupt me, no worries. Okay, then let's move on. Now I want to give you some details and the demo. And before we start with any more technical things, let's jump right into a demo. So 1 second, let me run this. I want to show you our current front end and how we envision how the whole fine-tuning potentially looks in 3 to 6 months. So here you see our front end, and I will use the Pokemon dataset that some of you might know to try to show you what fine-tuning is about. And what you see here is at the top, you see some of the query, which is 1 Pokemon. And at the bottom, you see 9 potential answers. They are somehow ranked. 0 is somehow the highest ranked from the model, and 8 is the lowest ranked. And they're even lower ranked, but they are not shown. And now I can, in this labeling tool, somehow label which are correct answers and which are wrong answers. So I can somehow say, okay, some answers are correct and some are wrong. And I have a model underlying. I will talk about the model a little bit later, but there's some model. And now in the future, ideally, you can now think about a search task. And for Pokemons, the easiest one and the most visual, graspable might be, okay, think about the color. Find Pokemons with the same color as a search query. And the model should somehow, without that I explicitly give the model training data, I rather implicitly label things, which the model then pick up in order to understand, oh, I have to look for colors. And let's say here, I first say, okay, for the green one, I label the 2 green ones as correct. There's another green one, I label again the green ones as correct, and get me the next. The yellow one, I label the yellow one as correct. This yellow one, oh, I don't get another yellow one, so nothing is correct. The pink one, I take this one. This green one, I take the 3 green ones. The gray one has 3 correct ones. There's another gray one, also 3 correct ones. The brown might get these 2. So this is some of what we envision in the future, that the person who brings the data just brings the data and we ask questions. And they might be more involved than what currently happens, but in the beginning, somehow there is somehow labeled some data and give the model some rough understanding what the model should look for. And let me continue a little bit, and then at the end, you already see the results get better. And let me just finish once through the 20 images and label them through. Before it always worked a little bit faster, but the reason is that I now have Zoom, which also takes some power from my CPU. Okay, now I labeled all the data. And now if I start from the beginning again, somehow look at all, we see, okay, they are somehow the right colors also at the front. Well, no surprise, I overfitted the model heavily to my data. So there's no surprise. If you know a little bit about machine learning, you would say, okay, he cheated like crazy. Fair enough, I did. But still, the point is still that this is how we envision the whole labeling process and the fine-tuning works in the future. So you see now all the colors are always at the top, but the model has somehow just learned what I showed to the model. So there's no surprise that it works, but still, this is, I would rather want to show you the workflow. So much for the labeler. And now I want to, before we go to another demo, I want to talk about what did we do with the first release and what somehow did we have in our current release of the Finetuner. So as said before, we have the 3 frameworks supported. We have a front end, which helps, you will later also see, helps not only with labeling, but mostly also for understanding your data and have a look into your data. We support CPU and GPU on these 3 frameworks. We have implemented 2 losses with different distances metrics, the Siamese and Triplet Loss. I will explain in a second what this means. We have some kind of tailoring where you somewhat can put in a model and then cut the model to your needs or play around with this. This is especially interesting when you want to understand how fine-tuning works good and how you can use a pre-trained model and what part of a pre-trained model you can use for somewhat getting better results. We have some tuner, which actually trains the model. And all of this is deeply integrated with the Jina core framework. So all the data that is processed are document arrays or document array mem maps. And we use the document type of Jina. So we try to leverage all the power that we get from the Jina core, our core repository, in order to get best results. Okay, so now let me explain the 2 losses. So I mentioned there's a Siamese and Triplet loss, and I want to explain you the rationale behind it and how they work, to give you some understanding how fine-tuning or some training for information retrieval tasks usually work quite well, and also fine-tuning. And we might, for the ML people in the crowd, we will most probably also introduce more losses in the future, but for now we decided on these 2 because they're kind of easy to understand and easy to experiment in the beginning with. The Siamese loss, the idea is you always show the model 2 images, and when the images somehow belong together, like these 2 pants, you try to pull them together, and when they don't belong together, like a shoe and a trouser, you push them apart. And the model tries to somehow push the results in the high-dimensional space, try to pull together always 2 trousers that belong together and push apart things that don't belong together. And just to recap, what is the output of a model? It's a big vector. So each of the things that you give to a model, like a pants or a shoe, like these images, after the model somehow is processed, you will get an embedding, which is a high-dimensional vector. So let's say 128-dimensional vector. And in this high-dimensional space, somehow the loss is designed in a way that the model pulls together the good ones and pushes apart the bad ones. And the Siamese loss always compares 1 pair. And this is done in a way that you somehow have your model, your network, and you copy it somehow. You have it twice with shared weights, and then you embed 1 document and the other. Afterwards, you get the embeddings of them. And at the end, from these 2 embeddings, a loss is calculated. And the loss depends if these are the somehow positive ones, that the embeddings should go closer together. Somehow the loss tries to pull them closer together, to pull the points in the high-dimensional space closer together. And if the 2 should go away from each other because it's a shoe and a pants, then the loss tries to push them apart. And the triplet loss always takes a triplet. That's why it's called triplet loss. And it always takes an anchor and then one positive example and one negative. It always takes these three. And that more or less does the same. It has this network somehow and calculates the weights for the anchor, the positive and the negative. So the embeddings. And then depending on this, it tries to pull together these two embeddings and push apart these two embeddings and then backpropagate this to the network and the network change its weights. So, yeah. And these are the losses that we are currently implemented and are the working horse somehow behind the tuning.
Max, we have a question from
Yes.
Christoph. Will there be a way to specify a custom loss function?
I think so, yes. Definitely there will be. Currently, I think it's not super trivial. You also, I'm not sure if you can do it currently, but definitely there will be a way to do it.
Cool. Okay.
Okay. Any other questions so far? Ha! As if you would have known that I ask for questions now. Okay, if yes, just interrupt me. That worked quite well. So, and now I want to look at the tuner. So the part that actually trains the model or tunes the model. And for this, let's first, I will use the fashion embeddings dataset because it's quite nice for showcasing things. And if you have never seen it, let's have a short look at how this dataset looks like. This dataset contains of a lot of some of fashion images, and they're categorized into 10 categories, like shirts, or I think it's shirts, pants, pullovers or jackets, dresses, other jackets or dresses, something like sandals, bags, yeah, and some more shoes, sneakers and boots, and whatever this is, another kind of overwear. And I would like to show you first somehow, I will now create a random model, and I will follow the Finetuner, so the documentation, our documentation. When you go there to fine-tuning MLP for fashion image search, I will more or less do what is written here. So if you want to do the same that I did, go to finetuner.jina.ai, and you can afterwards follow what I did.
Another quick
raised the hand.
question.
Yes.
Is there a way to sample how to specify how to sample positives and negatives for triplet loss? That's from Marco Bertini at the University of Firenze.
Yes. Tadej, perhaps you answer this because you're currently refactoring this. Is Tadej here?
I saw Tadej, and I'll open the microphone.
Yes.
Okay, Tadej, you're on.
Okay. Yes, we're currently just working on this. We will add basically different mining options, which is what takes care of selecting different triplets or pairs. And we will introduce things like hard negative mining, basically. So there will be an option to do that. Yes.
Great. And I see Joseph has his hand up. So Joseph, I'm going to open the mic for you now. Oh, no, hand's gone down. So
okay.
If anyone
it comes
wants
up again,
to ask in person, raise your hand, or, well, yeah, just raise your hand.
Cool. Yeah, so whatever I show you now, you can somehow play with, it's in the docs. And first of all, I use this simple model, which somehow gets as in features just the images that I just shown you, the fashion images, gets them to 128 dimension and then down to 32 with 2 linear layers and a ReLU in between, and that's all. So there's a really small model. And I will, let me close this one. And yeah, I will run this. 1 second. And now hopefully everything goes smooth because live demo is always, well, let's see. Okay, so what you will see here now is I will go through the images and use the labeler in this, not for labeling, but just for somehow exploring what does the model do. And all the results you see here are a random sampled image, and then the 9 closest somehow images to this one. And after the model somehow embedded them. When you look at this, you see, oh, here's a dress, but There are some pants, but also some dresses. Okay, this works pretty well. Sneakers also work well. This also works well. The sandals, there are also some other stuff which actually is not correct. Other sandals which doesn't work at all. So you see the random model sometimes works, sometimes doesn't work. But now you might wonder, first I want to explain why it sometimes works, because that's kind of weird, right? I just use a random model, you would expect random results. But that's not true. So let's look at the following picture. What I did now is I took all the images and treated the raw input of the image, so just the pixels, as a vector. So just concatenate all the pixel values like as numbers between 0 and 1 and treat them as a vector, which gives you a long vector. And then I did the PCA in order to get the distribution of the images somehow. And the colors here are the 10 different classes. So red might be shoes and orange might be boots and green sandals or something like this. And you already see in the input of the input data, it's already not random distributed, but somehow collected, because sandals look like sandals. So already the images look quite similar. And when you now choose a random model and apply somehow a random model on the random distribution, you don't get a random not a random distribution, but a non. So if you apply a random model on this distribution, which is non-random, what you get is also something which is not random. The model might have tilted the whole thing a little bit and shifted it around, but in the end, the distribution that you get is also not random. So here, the red might be again the shoes, and the orange the boots, and the green the sandals. But they're also, you see, not completely random. They're also still somehow have a certain distribution. And that's the reason why a random model somehow still performs on the fashion and is kind of okay. So not good, but something at least you see quite a lot of things are correct. And we hope now after training, we get this to look completely quite different. So we want to have the distributions go closer to each other so that the colors are more separate from each other. And I will show you, let's have a look how I created these images. This is one of the nice features of Jina. So I ignore a lot of the code here.
Can you bump up your font size, Max, so we can see more clearly? Nice, thanks.
This is better? Perfect. So what I did here is I have the embed function of the Finetuner. Let me just get the correct import. And let's say I have already read load my eval data, however it looks like, this evaluation data. And now I can just embed it with giving this evaluation data and my model that I also created beforehand. And then I can just say plot embeddings and somehow give and call it attribute, and then it works. So this is kind of nice feature of Jina that when you have your data in this shape, you can directly plot this. I found this really useful for understanding the data distribution. And apart from this, for just how I reached to the results here in the browser that I showed you before, I did, as I promised you, just copy pasting some of the model from the documentation and copy pasting the data loading, where I have a nice function for fashion match that you can easily play around with it, and also loading the then starting this interactive labeling. I set interactive to true, and then I get to the interactive labeling. And what I now want to do is I want to do the first optimize the model a little bit, and then afterwards look again at the data. So in this code, I will first read the data again with this magic function. This time I want 5,000 images, and then I want to use the triplet loss. So I need some positives and negatives. And I split my data to train and evaluation. For the sake of simplicity, I just do it like this. Split them. I train them with the train data. You will just see a summary in a second, and afterwards we will look at the interactive labeler again, and then we can see if the results got better. So fingers crossed. Train. Now I start some of the training process. This takes a moment. I guess now that since I'm streaming at the same time, it may take a little bit longer. So while this happens in the background, let me again go to how I created the images. So if you look at this code, data loading, somehow fitting, and then in the end, plotting summary. And this is the code that I use for creating the images. And the only things that I added here is that I somehow plotted once just the embeddings. Then I plotted somehow the random model. And after the training, I plotted the non-random. So that's quite useful for getting a grip of grasp on your data. Now, this may take a moment. Let's look at htop. No, perfect. The data preprocessing is done. What it now does, it is trains. This is some of the interface of our tuner. You see there is some, the first epoch is done.
Can you bump up the font?
Yeah, thanks for reminding me. So what you see here is you see the training loss and the evaluation loss. Both goes down. That's pretty nice. And now I have 5 epochs that I train. Again, both goes down. Potentially the evaluation loss now. Don't go down further. Let's see. Oh, it did. Woohoo! Okay, and now you somehow see the print of the loss on the left-hand side for the training, on the right-hand side for evaluation. It's not the nicest print. We want to do it in the future rather. Currently, you see for every batch the value. We know this is not perfect. In the next version, next version, this will be different, either by epoch or by time. So we know, but still you see somehow that the loss goes down for training and for evaluation. Some of the tendencies can be seen. And now it will index the data again and open up the labeler. And then we can have a look at how the results look like now. This will take a short moment. If you start the whole thing and you don't see so much logging, I forgot to disable the debug logging. Since I'm a Jina developer, I by default always have debug logging enabled, and that's why there's so much happening here. I'm sorry for forgetting to disable it. So 60%, almost done. Here we go. And now let's again look at 30 images. And now it's a live demo. So hopefully we see now better results. Let's see. Okay, dress. Looks like dresses. Another dress. Oh, no pants anymore. Woohoo. Shirt stayed good. Sneakers is good. Shirt stayed good. Sandals, all sandals. Again, all sandals. Woohoo. And yeah, shirt got shirt. Shoe, boot got boot. So looks like results look better now. And this now, this time I somehow choose the training data and evaluation data to not be the same, just to make sure. This time I didn't cheat. And okay, fashion MNIST is quite an easy data set. So you might say, okay, I can also do this. That's true. But we also played with more complex data sets, which are not so good for live demos, where we got also not too bad results. And I hope that in the future we can also write a blog post or so about better results.
Which data sets were they, Max? Which data sets, out of interest?
We played a little bit with some Simpsons images. We played a little bit with some Celeba, with the Celeba data set, some also which you can find in the documentation, I think. Yes, the celebrity face search, and with some others. Okay, so much for the tuner. This is how the tuner looks like. Then, this I already showed you. Why is this now? Random rates I explained to you. And for some comments more on the tuner. So we have tested it on general linear models like LSTM or VGGNet, but it doesn't work with transformers yet. We are currently looking into it, and in the next weeks or let's say 4 to 6 weeks, hopefully transformers are also supported. Because we know, especially when you do text, transformers are needed to get decent results. Okay, and now let's have one more look into the documentation. And there is this in the components, there's this overview. And there I already talked about quite a lot about these components, but now I want to explain again in a more structured way what these components are and shed light into it. So in general, I talked about the tuner already. So when you have labeled data and you have a model which outputs embeddings, you can use the tuner to get a fine-tuned model which outputs embeddings. In case you have a general model which might output categories or something which is not directly somehow usable as an embedding, you can use our tailorer. I will show in a moment how this works to somehow create a model that can generate embeddings, and then again the tuner to get a fine-tuned model. In case you have an embedding model but unlabeled data, you can use the labeler to get labeled data and then the tuner again to tune your model. And in the case you neither have an embedding model nor labeled data, you can combine all of this together and in the end somehow get again a model that you can use in Jina for getting better search results. Any questions so far? Let me take a break here for a moment.
There was one on YouTube about where they can get the slides afterwards. So if you want to see these slides, go to our Slack general channel, either later today or sometime tomorrow, and we'll get the slides there in PDF format for you to download.
Yes. And I actually created a small repo with my code, but the code is also mostly in the documentation. So I think I would just take the documentation. Everything's in there. And especially if you look at this video in 1 week or so, or in 2 weeks, then the documentation is more up to date than my code. So I rather recommend always going to the documentation.
And you can access that documentation at finetuner.jina.ai.
Yeah. Cool. Then I promised there is this missing piece, the tailor, and I want to go into this one. And so let's have a look at the tailor. You've seen this image before. Whoop, I've already opened this one in a light mode. So this image is somehow explains quite nice what the tailor does. So the idea is when you have a general model, the tailor allows you to analyze this general model and gives you tools at hand to create an embedding model. And for this, you can do mostly 3 operations. You can add a layer to your general model, or if you want also multiple layers. You can chop off part of the original models if this is somehow not interesting. Might be that when you take an original model, somehow something you have some downstream task which can be just ignored, and you somehow just take your can cut it off at some point, and then just add your last layer. And you can also freeze it. You can say, okay, I only want to train 1 layer. I don't want to train the layers before, so I freeze all the layers before I start the tuner, and this speeds up might speed up the whole fine-tuning process. These are the 3 basic operations that you can do. And now let me show how you can do it. So again, I guess I increase the font size. And is it big enough?
Yep.
Perfect. Okay. So you can, first I import. We have 2 main functions here, display and to embedding model. And I will show how to use these 2. So for the sake of simplicity at the beginning, let's take the model that we already have seen before. And let's use the display function. Now you see, oh, this model has 4 layers. Well, fair enough, that's true. And you see, okay, some of these layers are trainable. Well, the layers that have parameters, if you don't have parameter, you can't train. Cool, so you directly see this. And you could choose the green layers as actual embedding layers. So when I want to somehow use some of these layers for my embedding in the search, I could use them. And the reason is they are all 1-dimensional vectors, so they are good to use. And now let's say that's nice, but actually that's 32 is too big. I know my problem is so small. I know 10 dimension as the output as embedding would totally suffice. I can use the 2 embedding models, again, put in the model, my input size. For PyTorch and Pedal, this is pedal, this is crucial to also define the input size. And I say output dimension should be 10. And then let's have a look at the new model. What happens? Well, there is a new layer. And you somehow can now directly train the new model. The nice thing is the interface is the same regardless if you have a Torch, TensorFlow, or Pedal model. The interface is always the same. So you can always create output dimensions and more operations. I will show you some operations. But before, let's look at a different model. Let's use AlexNet, which is a pre-trained model. I want to use a pre-trained one. And I use AlexNet not because it's very good and very performant, but because it's still fits on one screen. And we still can see the whole model somehow. The description of the whole model still fits on one screen. And here you say, okay, the convolutional layers are not really suitable for embedding layers. So if you want to take directly an embedding layer, you have to use one of the green ones. And yeah, this is somehow, you already see this, you know, okay, oh, there are also quite some trainable layers. And what you can do now is you can do different things. You can say, okay, I actually want to cut the model at layer 16. So I promised before you can chop off the model. So what you do is you say embed model to embed model. Again, input size, and you say the layer name should be linear 16. And then I display it again. And you see everything after layer 16 is just the identity, which is doesn't have any parameters, so it's just forwarded. Now let's say I want to also change the output dimension. So it should be 128. For some reason, I don't want 4096. Might be when I index it, put it in files quite big. So that takes a lot of memory. Also, for most problems, this is way too big. So much smaller space is totally sufficient. So let's reduce it to 128. What you see now, after my layer 16, layer 17 was introduced, which reduces now everything to 128. And now I say, but actually I only want to train the last layer. I don't want to train anything above. Now all the others are freezed and you directly somehow only train your last layer. And we use mostly this tool for playing around and somehow understanding how we can shop off models. What is actually a good way to shop off models? What should we freeze? What should we not freeze? And so on. And this, and this gives us also the freedom. We want to be framework agnostic to directly experiment with TensorFlow and Torch without needing to think, oh, what is the actual syntax of TensorFlow or Torch all the time, but actually just have one unified syntax, which allows us to play around really fast. So much for the tailorer. Any questions towards the tailorer? I wait a moment if there is something. If not, I'm happy to continue. Well, let's say no. Okay, then let's continue. So after I showed you somehow what are the three main parts, the tuner, the tailorer, and the labeler. Now let's see what will most probably happen in the next weeks and what are the next features that you can wait for and be excited about. So one is, as already today mentioned before, we want to support hard negative mining. We also, as I mentioned before, support transformers because especially for text data, but also for image data, they're quite powerful. And if we don't somehow support them in the medium term, then it would be, it's important that we definitely support them. And then most probably we will support some kind of catalog and query differentiation. So what you have seen until now is that when I somehow had a query, the query was always also part of the answers. But in the real world, this is often not the case. When you have an information retrieval system, you have your catalog, you have your things that are searchable, and the queries are user generated. So they're random. Often they're so random in the sense of they're out of your control somehow. You can't know all the queries beforehand. And so and they're not part of your catalog, some of the things that are searchable often. And for this, the Finetuner will most probably allow you to split these two data sets from each other in the future. And such that somehow also when you label, you see really queries at the top and then at the bottom, answers from your catalog, which is actually, whenever you have a search, often this is the case. Sometimes also not. Sometimes the search is also just inside the system, but then it's usually a recommendation. And what we want to add for the tailor is potentially model tuning and model compression. this potentially also happens in the future. And as you can already guess, we published 0.1. So please don't be surprised when we do refactoring and break things from one release to another. That might happen in the future. Yeah, I think when you have a fresh tool, this is kind of usual, and we just also want to be open about it. This is what happens. We try to be backward compatible as much as possible, but sometimes it's hard to get around breaking changes. Okay, that's it for the Outlook. Now, if you want to get started, just run pip install Finetuner, and then you can start play around with the code. And I'm ready for any further questions.
Okay, and we can also open it up to the floor for questions about Jina in general, you know, what's coming next, or if you want to talk about the project you're building with Jina, or that you have in mind to build with Jina, let us know. We're more than happy to answer any and all questions. And it's good to see so many people here today, a lot of new faces. Always love seeing that. Okay, can you describe the workflow between trainer and fine-tuner, says Joseph.
What is exactly trainer? So we have the tuner, we have the tailor, and we have the labeler. So I guess you can either mean that the workflow between the tailor and the tuner.
Trainer.
Tailor. Okay, tailor and fine and tuner. So yeah, what you can do, let's get our hand dirty. So what you can do when you load a model, like let's say this AlexNet that we have here, and we cut it down to wait, let me just copy this line and go to the train that we had before. And then let's also from finetuner dot tailor import to embedding. I hope this is the right syntax. So what I can do now is before I do the fit, I want to, let's say, and that's also. So now I ignored this get model before, but somehow I vision. So now I should be set. So I get now the model with the AlexNet. I do whatever I want to the model, and then I have my embed model and just put it to the tuner, and then I can tune it. There might be more elegant somehow things in the future where we say, okay, automatically try different setups or whatever might be the future. But for now, this is how you can do it. You can just somehow create your embedding model, and then you can just directly fit it into the training pipeline.
Good stuff. And oh, sorry, go on, Max.
Nope, that's it.
Cool. And we've got a question from Elena. In which areas do we see the highest potential for fine-tuner?
I think the fastest successful results, is my wild guess, will be in anything with images, because it's easier to label images. It's much harder to label text because text information in text is much denser. So labeling text is, you must be much more careful about what you label. And the people that label images, it's usually easier to explain to them, oh, look, Pokemons should have the same color, please label it for me. If you say text, the amount of, when you just read a text, let's go back to the example of shirt blue dogs. What you can read in the sentence, everybody heavily depends on your current background, of your current also mental state. And so it's much, much harder to actually annotate text. So I believe text will not be the fastest one, but images, we will have more somehow success early on with images. Or also, I know from some other projects where I was part that somehow images works quite nice. And I guess there will be the first applications.
Nice. Thanks, Max. Okay, and another one. Oh, thanks. You're welcome.